System's a Labram HR800. Labram is the model. HR stands for high resolution, and 800 is referring to the internal focal length of 800 millimeters. The system comes equipped with 3 objectives: 10, 50, and 100 M-plane Olympus objectives, and the system is also equipped with 2 lasers. We'll start with buttons and switches. Over here, this is the system control box for the unit. There's a power light, lets you know the system has power. Here's a laser on-off key. Key does nothing. This would be used on a 633 nanometer laser, but the system is not equipped with one. This is a laser key switch to turn the Heaney laser on and off. You guys do not have the Heaney laser, so it does not do anything. Next is a diode on-off switch. This is an internal alignment diode mounted inside the system. It is only used to check the alignment and should always remain off. If ever you come in and you get system saturation and crazy readings, it's because maybe this diode is turned on. Next is shutter, micro, up for micro, down for macro. Micro referring to microscope. This switch will always be in the up position because you do not have any macro accessories. If for some reason the shutter is not working on the instrument, maybe it's because somebody has flipped the switch down into the macro position. This should always be up. Next is a line scan feature, scanner on-off switch. The system is not equipped with a scanner, so no matter what you do with the switch, it does not matter. Next, camera on-off button. These are used to power our older video cameras on or off. This system is not equipped with one of those cameras, so this switch also does nothing. Over here is a laser on-off switch. It does not actually turn lasers on and off. Only thing it does is raises a blade shutter in the back of the system to stop the laser from entering the system. And next over is a shutter switch for shutter 1 or shutter 2. This switch is to control multiple shutters from multiple detectors. As of now, the system only has 1 detector, so this will always remain in the shutter 1 position. If for some reason it is in shutter 2 position, you will hear the shutter make a chattering sound, and the shutter will not respond to any other commands from the system. Over here is our joystick. It is used to control the motorized stage. X, Y, and rotate joystick for Z control. This is white light source for visualization of your sample. It's got a simple knob, turn on, off. More buttons and switches coming over. This is our XY motorized stage with a Z motor attached to it. And if you see over here behind this camera, we have several buttons and switches. Here is a pull stem behind this camera. It says pull for visible mode, push for UV mode. This stem will always be pulled out. In order to use UV mode, you would need a UV laser, a UV detector, and UV gratings. Next switch over is another push-pull stem. It says pull for synapse or push for the 3rd detector, which is not mounted yet up top. So as of now, this stem will always be pulled out. If you ever go and try to acquire data and you get absolutely no data and you hear the shutter clicking, check, because maybe someone had pushed this stem in by accident. Over here is another push stem. This is for another CCD. Again, there's no other CCD mounted on top, so this should always be pulled out. If anytime you get no data, check all 3 of these stems and make sure all 3 are pulled out. Coming around the corner is our CCD. This is a Synapse CCD for use in the visible range. This is the CCD, and this is the CCD power supply. Temperature of the CCD should be set to -70, and the display on the computer should read -60. And here is your serial number of your system. Someone asks you what kind of system you have or what serial number, you will need this information here so they can look your system up in our computer. Next, laser power supplies. The red box powers the 532 nanometer laser, and the white and blue one powers the 785 nanometer laser. Every night when system's not in use, we recommend you at least power off the lasers. Powering off the red laser, just turn the key, or the green laser, just turn the key off, laser turns off. To power off this 785 laser, just hit the on-off button here. That'll stop the laser from glazing. If you wish to power down the controller, you press the power key on top, and that will also power down the control unit. This is our three-section laser bench. Bottom laser is the 50 milliwatt 532 laser. Top is the 100 milliwatt 785 laser. Here's our optical tower with a motorized switching mirror inside the middle box to select between which laser that you want. The laser selector box is controlled through the software. The laser power supplies are not controlled through the software. One around here, black box here. This is the controller for the motorized stage. If ever you come in, the motorized stage ain't working, just confirm that this box is actually powered on and working. Little white box below it is a power supply for an autofocus device. Also, both are powered on. And over here is just the back of the LabRam main electronics box. If the time comes that you get a second detector or a second CCD, here is where you would plug in for a secondary shutter command to sync your second CCD along with the software. And that covers buttons and switches and